What is a vector quantity? Any physical quantity which has magnitude, which has direction, and third important part is it must follow vector algebra. Why first two were not enough? Because current has magnitude, current has direction, but it doesn't. Current has magnitude, it has direction, but it is not, this is not a vector quantity. Therefore, you must remember that these two are not enough. Physical quantity has to have magnitude, it has to have direction, and it must follow vector algebra. Only then that physical quantity will be called a vector quantity. How do we represent a vector in symbolic form? I will write neatly, don't worry. Just be patient. We have just started. So, representation of a vector in symbolic form. Any vector, when it is written, it is always written as a vector, an alphabet with an arrow on its head. This is the representation of a vector. Now, if you are mentioning only the magnitude of the vector, then the magnitude is this. And this can be multiplied by a unit vector. And always remember that any vector has its magnitude and a direction. And direction is in the direction of uh, the same vector. So if I want to find a unit vector in its direction, I can always divide a vector by its magnitude and I'll get a unit vector in that direction. For example, suppose I tell you I have a force, this is x-axis, this is y-axis, and I have a force in this direction. This force is, say, 100 Newton force along x-axis. So I can write this vector as this force as 100 Newton I cap. Dear children, I have been specially requested that I should be teaching in English because there are a lot of students who have joined us from Karnataka who wanted me to speak in English. Hindi will become a big problem for them. That's why I'm trying that I should teach in English. So please bear. Now, so force can be written as 100 Newton I cap. I cap is a unit vector along x-axis. Now, if I divide the force by its magnitude, this force will become divided by 100, will become a 1 Newton force along, will become a unit vector. There will be no unit because 100 Newton divided by 100 Newton magnitude. So this will not remain, this will only remain a unit vector along the x-axis. 1 Newton nahi hoga. 1 Newton divided by 1 Newton. This will be dimensionless and it will be a unit vector along x-axis. So please understand what is the meaning of unit vector. It is giving you a sense of direction. A unit vector I cap is a vector with magnitude 1 unit and direction is along the x-axis. Direction along x-axis. Now, and this is how we represent a vector. The geometrical representation of a vector. So any vector, when we represent it geometrically, the vector has this point is called its tail and this point is called its head. Now, if you are going to draw this vector anywhere in space, suppose you take this vector from here and draw it here. Keeping the sense of direction and the length, magnitude same, the vector remains the same. If you keep the direction and length, magnitude same, intact, then the vector remains the same. You can draw it anywhere in space. That's why they are called free vectors. Dear children, I am really sorry. I cannot speak in Kannada. So please bear. I can either use English or Hindi. Kannada, I cannot speak. So please bear that. English, I was told, will suit everyone. So now, uh, now coming back to, thank you. Okay. Now, this length of a vector is proportional to its magnitude. I'll be quick, don't worry. I am just starting from scratch and trying to ensure that every child understands everything. I'll be moving very fast, don't worry. Length is of a vector is proportional to its magnitude, and the direction obviously is represented in the same direction as the vector. This is the geometrical representation of a vector. What are axial vectors? Sometimes when we have a body which is rotating, suppose there is a point mass which is going on in a circle and the point mass is moving around in the circle like this. If this is the axis of rotation and the point mass is going in the circle in this direction, suppose like this. It's moving in the circle like this. Now, what will be the direction of angular velocity? Now, such vectors are called axial vectors, where the body is rotating about an axis. So this point mass is undergoing a rotational motion about this axis. And screen is not clear. I'm surprised. Okay. Axial vectors, yes. Either we represent it. So omega. So it is rotating like this, and angular velocity or angular acceleration. Angular velocity, the direction of angular velocity. Now, if you curl your right hand fingers in the direction of this motion along this, your thumb will represent the direction of omega. So this will be the direction in which your thumb will point. If you curl your right hand fingers in the direction of motion of this body. So omega will be upwards. Some people write it clockwise, anti-clockwise, but please try to understand that that's a little confusing thing, because from one side, same thing which appears to be anti-clockwise, from the other side of that motion of that plane, you will find it clockwise. So this is a better way of writing angular velocity in terms of, so angular velocity will be in this direction. And if, wait, sorry. If this will be the direction of angular velocity for this motion, if suppose the same motion, same circular motion was happening in opposite direction. Suppose if the body was rotating like this is the axis of rotation, and the body was going this motion. Now try to use your right hand thumb rule. If you curl your fingers around this, if you curl your fingers in this direction, you will see your thumb will have to point downwards, and the direction of that angular velocity or angular acceleration will be downwards. So this is how you find the direction of angular velocity when you are dealing with rotation. So this is another example. Now, what is a unit vector? A unit vector is defined as a vector divided by its magnitude. So you know that for x-axis, y-axis, and z-axis, if we have defined unit vectors, we have along x-axis, the unit vector is called I cap. Along y-axis, the unit vector is called j cap. Along z-axis, a unit vector is called k cap. Now, if suppose I tell you, I move 10 meters along x-axis 10 meters, and I move 5 meters along y-axis, and then I'm moving, say, 15 meters, 20 meters along z-axis. Now, this becomes very difficult to represent on paper, but I can write this in vector form very easily. And the vector form will be 10 I cap plus 5 j cap, 10 I cap plus 5 j cap plus 20 k cap. This will be the total displacement from origin, and this will be the displacement of the body. So this is how we write anything in the form of unit vectors, where unit vector I, j, k are along the x-axis, y-axis. Why is screen not clear? I'm surprised. 1 second. I'll try to see if there is any problem with the screen. I'll try to clean the... Okay. Now, is it better now? Yeah, I'm coming. The concepts. Okay, what is a unit vector? Now suppose, what is a null vector? A vector which is having zero magnitude is called a null vector. What are equal vectors? If there are two vectors which are in the same direction and having same magnitude, they are called equal vectors. Suppose I have a vector A, which is in having this length. This is suppose vector A, and I have another vector which is same length, same direction. Then this vector will also be A. If I have a vector which is in opposite direction, it'll be minus A. If I multiply a vector by negative of a vector is opposite direction. So if the moment you multiply a vector by minus, the direction becomes opposite, the magnitude remains the same. Just pay attention and have a look at it. What are parallel and anti-parallel vectors? When two vectors are in same direction, they are called parallel vectors. When two vectors are in opposite direction, they are called anti-parallel vectors. So these two vectors are anti-parallel. These two are in same direction. They are called parallel vectors. Collinear vectors, when two vectors are along the same line. Suppose I have a vector this is A. Then I draw another vector which is along the same line. Such vectors are called collinear vectors. A and B are collinear. They are acting along the same line. Now, what happens when we multiply a vector with a constant? Suppose I multiply a vector A by 3. What happens to the vector A? Its magnitude becomes 3 times, its direction remains same, and it becomes, this is 3. So please understand, when you multiply a vector by a number, it just affects its magnitude, not the direction. Unless the number is a negative number, the moment I multiply a vector by a negative number, suppose -1, in that case, the direction is opposite, changed. So please be careful about it. Now, multiplication of a vector by a scalar. When we multiply a vector by a scalar, its magnitude changes and its magnitude becomes that many times. Suppose I multiply this vector by 4, so it'll become like a 4a vector. The length will become 4a, direction remains unchanged. So this will be 4a. Now, coplanar vectors, when vectors lie in the same plane, they are called coplanar vectors. I'm very quickly brushing you up through vectors so that you are able to understand the full mechanics properly, because for us, vectors are going to be very, very important. When many vectors, they lie in the same plane. For example, I'm drawing a vector A, I'm drawing another vector B, another vector C, and all these vectors, they are lying in the same plane, which is the plane of my screen. These vectors are called coplanar vectors. The moment I draw a vector which is not, suppose I draw a vector like this, you should understand what is the meaning of this dot and what is the meaning of this cross. You have to understand this. So this means if you are looking at an arrow from the front side, that arrow is coming out of the plane, then you represent it like this. So a vector which is coming out of the plane is represented in this way. You draw the front side of the arrow. And if an arrow is going into the plane, then you are looking at the arrow from behind, and this is how you draw it across into the plane of the board. So these are not going to be in the same plane as A, B, and C are. So coplanar vectors are in the same plane, and vectors which are not in the same plane can be represented. And we are coming to physics problems. Don't worry, I'm just working on your vectors part. Orthogonal vectors, vectors which are mutually perpendicular, making an angle 90 degrees with each other, are called orthogonal vectors. How do we resolve a vector? Now, this is something which is very, very important for all of you, and everyone should pay attention. If you have a vector, now the story begins. If you have a vector A and you want the vector to be, one second. I will be writing it. So if you have a vector A and you want to break it into two components, one component must be along this direction, which is making an angle theta with it, and the other component is in a direction which is perpendicular to it. Now, how do you break or resolve this vector A into these two components? What you need to do is you draw a perpendicular from here to this. This is 90 degrees. If suppose this vector magnitude is A, in that case, this component is A cos theta. I am sure you might have learned it. And this component is A sin theta. And this direction will be in this direction. This vector will be in this direction. So on adding A cos theta and A sin theta, you will get, so if you have any vector, suppose A vector, and you want to break it into two components. So if the direction in which you want one component is making an angle theta with it, the component of this vector in this direction will be A cos theta, and the component which will be perpendicular to it will be A sin theta. These two are very important to know. How to break a vector into two mutually perpendicular components. And I expect that when we are in 12th, we know this much. And this should be the basis of what we'll be learning ahead. So rectangular components means when we break a vector into mutually perpendicular components. So if we are dealing with 3 dimensions, we will have X, Y, and Z components of a vector. And we will be writing those vectors as, suppose I have a force vector in 3D, which is 10 I cap plus 5 j cap plus 3 k cap. Now, suppose this is a force vector, which I am representing in 3D. Now, the X component of the force is this, Fx. This is Fx. The Y component of the force is Fy, and the Z component of the force is Fz. If I want to find the magnitude of this force, dear children, I'll be answering your questions. I'll be replying to your chat for sure. In between, when you are typing something, it distracts me and I keep reading your comments. So please let me concentrate on teaching. I cannot keep saying hi to you in between while I'm teaching. So please be patient. Now, so if I want to find the magnitude of this force, the magnitude will be root of 10 square plus 5 square plus 3 square. All this you should know. And if suppose you have a force vector which is having, say, x-axis, y-axis, and I have given you that the x component of the force is 10 Newton, y component of the force is 20 Newton. Suppose in that case, I ask you, what is the magnitude of this force? So all you have to do is you have to complete the parallelogram. You already know this method, which is called parallelogram method of vector addition. And you will complete this parallelogram and you will say that the Pythagoras theorem will tell you that the magnitude of this vector resultant will be root of 10 square plus 20 square. This will give you the magnitude. How will you define this angle alpha? This angle alpha will be 10 alpha will be equal to this side A, B, O, AB upon OB, and that will be 20 divided by 10. So you can define a vector in the form of its magnitude, which is this, which will be 10 root 5, and magnitude is this, and the direction can be represented as shown in the figure at an angle alpha. So given a vector in the form of I cap, j cap, you can find its magnitude and direction. Now, so please remember this. I have summarized it here that if you have a vector A and it has two components, AX, AY, then the magnitude of that vector can be written as this, root of AX square plus AY square, and the angle which the vector is making with x-axis is given by tan theta, is given by tan inverse. Theta will be tan inverse AY by AX. Just remember this result. Now, there are four different operations of vectors that we need to understand: addition, subtraction, multiplication, division. So a vector cannot be divided by another vector, so division is ruled out. Now let's focus on, so three things you will have to understand. One is addition of vectors. For addition of vectors, you have two methods. One is the triangle method, which is being shown to you right now. If you have two vectors, one vector is AB, another vector is BC, so you keep the tail of one vector on the head of another vector. Let me just make it a little thin. Yeah, this is good. Now, on the head of one vector, you keep the tail of the other vector. And now, this third side of the triangle will give you the resultant vector A plus B. So AC is the resultant vector, and resultant will be the third side of the triangle in this order as shown in the figure. And this is called triangle law of addition of vectors. Now, there is another method where you add vectors in the form of parallelogram law. Now, let me show you parallelogram law. The same two vectors which we had, suppose I have a vector A, I have another vector B, and I want to add these two vectors in the form of triangle method. Triangle method will be you take one vector, pick one vector, 1 second. You, in triangle method, you pick this vector and place the tail of one vector on the head of another vector. Now, the third side of the vector, will give you the resultant of the triangle. This third side of the triangle, when completed, will give you the resultant A plus B. This is called triangle method. Now, instead of placing the tail of one on the head of another, if the same question was dealt with, if I bring the same vector B from here, instead of placing it here, I try to bring this vector here. And wait. Now, sorry. Now, if I draw this vector, here, if I place the tails of the two vectors together, so B can be drawn anywhere, and I am going to draw B and keep the tail of B at the same place where the tail of A is kept. Now, this is also vector. One second. Now, I will draw the vector B same as the earlier vector. This vector is parallel to B and same in length. So this vector is also B vector. If I place the tails of these two vectors together and then I complete the parallelogram, this method, this diagonal will give you the resultant. So you can see by triangle method also, you got the same resultant, which was in yellow, and by parallelogram method also, where these two are the two sides of a parallelogram, you are getting the same resultant, and therefore both the methods will give you the same answer, and they are not two different methods. They are just two ways of saying the same thing, and you get the same resultant in both the cases. So I have explained to you the triangle method and the parallelogram method of addition. Let me also quickly show you that if I ever draw a triangle and I ask you how they are related, let me ask you this question. So in this case, what can you say? Is this true or is this true? Which case is true? Please tell me. Let me see how many of you give me the right answer. A is true or B is true? In this diagram, what can I say? Which is the correct option? Quick. So you have to note that, you have to understand that if you observe, you will find that the vector C has vector A's tail is kept on the head of vector A, and this third side is representing the resultant. This is the resultant. So what I can see is C plus A. C plus A is equal to B. C plus A is equal to B. So A and B both. A plus B is equal to C is wrong. B plus C. B plus C is equal to A is also wrong. So the correct solution is this. I intentionally gave you two options which both were wrong. So you have to understand that if direction you have to understand. So which direction? The vector C was in this direction. Vector A was in this direction. And if you observe that on the head of C, you have kept A. Now, this vector plus this vector will give you the resultant, which is B, and I have written the correct answer. So none of the A or B are correct. It is C plus A will be equal to B as shown in the figure. So please be attentive. A and B are wrong. Please understand this. I cannot say A plus B is equal to C. I cannot say this. I'll tell you what is wrong in this. Please pay attention. Yeah. So A plus B, if you have to add two vectors, so you have drawn vector A like this. Now, the tail of B should be on the head of A, but here you have the head of B. Now, you cannot add vectors like this. So this is wrong. Second is, why is B plus C wrong? Please pay attention. Why is B plus C wrong? Look at B and C. Their tails are kept together. B and C, their tails are kept together. If B plus C has to be added, then the parallelogram which will be completed, this resultant will be uh, B plus C. But B plus C, they are saying A, which is not true. So both the options are wrong. So you have to be attentive. And this was the correct option. I just trapped you people. Anyways, be attentive and keep learning. Let's see. आगे चलते हैं. What is parallelogram law? I just explained that if you draw the two sides of a two vectors are representing the two sides of a parallelogram, vector A and B, their tails are kept together. In that case, the resultant, you complete the parallelogram and the resultant will give you A plus B. And this has been explained here. And this diagonal will represent A plus B. What if I ask you what will be A minus B? Just pay attention. What is minus B? Minus B is a vector which is same as B in magnitude but opposite in direction. Please pay attention. Minus B is a vector which is same as B in magnitude but opposite in direction. So if this vector is B, can I say minus B will be this vector? This vector will be minus B, opposite in direction. Now, if I want to find A minus B, what I have to do is, please pay attention. All I have to do is, we will do this A plus minus B vector. Now, once you know minus B vector, which is opposite in direction, now we will try to add A vector and minus B vector. That will give me A minus B. And this will be, so I'll draw minus B vector. I'll try to bring the tail of minus B on the head of A. Let me just decrease the size of the diagram. So this minus B vector will be like this. And it is, I have kept the tail of minus B is this. Tail of this is kept on the head of A. And now if I add these two vectors, this will be the resultant. So this diagonal represents A minus B. And this diagonal represents A plus B. Please be careful, attentive. Now, yeah, sure. This full class video will be shared with you, don't worry. Okay. Now I'll be coming to more interesting part very soon, but just let's get done with vectors quickly, fast. Now, if I have two vectors A and B, and I want to find their resultant, just pay attention. This formula you all have to remember. So there was this vector A, which is from P to Q. This is vector A. And I have another vector B, which is from R, P to R. This is vector B. And I want to find what will be the resultant. One thing I want to explain to all of you before we go ahead with that. So suppose you have two vectors. What is the meaning of angle between the two vectors? Please note it down, all of you. Angle between the two vectors. Please understand this. What is the meaning of angle between the two vectors? If suppose you have a vector A and there is another vector B, and I want you to tell me what is the angle between two vectors. You bring their tails together. You draw it here. This angle, theta, is called the smaller angle between the two vectors. When their tails are placed together is called the angle between the two vectors. Please remember this. Now, if suppose I ask you a question based on this, and I tell you there is a vector A, there is a vector B, and I tell you this angle is given, and this angle is say 150 degrees. This is vector A, this is vector B, Yeah, we'll come to questions. Don't worry. Uh, so let me move fast. So the angle that you have to, the angle between the two vectors will be this angle. This angle is defined as the angle between the two vectors. You will bring the tails together, and then the smaller angle is called the angle between the two vectors. Now, so if you have two vectors, what is the resultant of those two vectors? The resultant force is a square plus b square plus 2ab cos theta square root. Please remember this formula. And the angle which the resultant will make with vector A is defined by alpha, and that alpha is given by b sine theta upon a plus b cos theta. Please remember these two results for sure, because they will help you solve questions very fast. Now, let's take few questions based on previous year's question papers of IIT JEE Mains so that you get a glimpse of what is being asked. So have a look at this question of previous year. The sum of two forces P and Q is R. So he's saying the sum of two forces, he's saying P plus Q vector is equal to R, such that magnitude of R is equal to magnitude of P. This is given. The angle theta in degrees that the resultant of 2P and Q will make with Q is, please try to answer this question. This is IIT JEE Mains question in 2020. Please try to do this question. The sum of two forces P and Q is R, such that the magnitude of the resultant is same as the magnitude of P. So, and the angle theta, which is in degrees, that the resultant of 2P and Q will make with Q is the angle theta in degrees that the resultant of 2P. So there is another vector 2P. So suppose, let me just draw it for you. So there is a vector P and there is a vector Q. Suppose this is vector Q, this is vector P, and he's saying that the resultant of both the vectors P and Q is equal to P. So I can say, suppose the magnitude of Q is Q. So I can say, if I have a triangle, I can say for sure one thing, that the two sides are same. So if P is one vector, suppose this is P, and this is another vector which I'm adding to it, and this is the vector P. So the resultant of P and Q, this is Q. Now the resultant is the resultant vector I'm showing by yellow. Please pay attention. Let's see. Many of you have given your answer. Now let's try to solve it. So this, he is saying that is the resultant, and he's saying that the magnitude of resultant and magnitude of P are same. Therefore, these two sides are same in this triangle. Now, it's an isosceles triangle. Now, angle theta in degrees that the resultant of 2P and Q will make with Q. If I have another vector 2P, it'll be double the length of P, and Q will remain same. So I will have this vector Q. This is Q. It is same as earlier in the same direction. And this is P, which will be 2P. This vector is 2P. Now, what he's saying is the angle which the resultant of these two will make, this is the resultant of these two, will make with Q. This angle he is wanting to know. This is, say, phi. We have to find phi. So a lot of you have given me your answer. Someone is saying 90, someone is saying 60. I want you to find this angle. So how do we find this angle? So we just learned a formula where we learned how to find the angle with a vector, and we also know the magnitude. We just have to use these two formulae and we'll get the answer. Just be attentive and see how will we be doing it. Let me do it neatly for you. I was trying to explain to you the question till now. I'm rubbing this, and 1 second. How do I rub this? Okay. Now, just see this. So we have a clear screen. Now, let me solve this question for you. And this is an IIT problem. It will help all of you to understand that if R and P max. So how do we write the resultant? Resultant of two vectors is given by root of P square plus Q square plus 2PQ cos phi, if phi is the angle between the two vectors. Okay? Now, and resultant is given as P only. This is mentioned. So I'll keep resultant as P and square both the sides. P square is equal to P square plus Q square plus 2PQ cos phi, where phi is the angle between the two vectors and these will get cancelled. So you will get a condition that Q square, wait a second, Q plus 2PQ, Q common, 2P, sorry. 2P cos phi, sorry. Is equal to 0. This is one condition which we derived. This will get cancelled. So we have a relation between Q and 2P cos phi, Q plus 2P cos phi, where phi is the angle between Q and P. This is equal to 0. This is one condition that we have obtained from using this information. This is one. Now, when we want to find the angle between the resultant of 2P and Q, so you know how do we find the resultant angle? Tan alpha is given by, tan alpha is given by, tell me, what is the formula? If it is with vector A, then A comes once and the other vector comes twice. So here you can see, I can write, if we are asking for the angle that the resultant of 2P and Q will make with vector Q. So angle with vector Q, suppose that is tan alpha. Tan alpha will be 2P sin phi upon Q plus 2P cos phi. Now, how will you find this? Q plus 2P cos phi is 0. Therefore, this will become 2P sin phi divided by 0. And when this condition we got it, so this will be undefined. Therefore, alpha will be pi by 2 infinity. So tan alpha is in one something upon 0, which is undefined, and therefore alpha is pi by 2. That is the answer. 90° was the answer which many of you gave. I'm quite happy. Good. Now let's go to other questions. Addition of more than two vectors, polygon law. You already know, when you keep adding on the tail of one, head of one, you keep keeping the tail of other. Subtraction of vectors, we have understood. We will do more questions now. If the two vectors A and B have equal magnitude, if the magnitude of A plus B is equal to 2 times the magnitude of A minus B, then the angle between A and B will be what? So let's assume the angle between A and B is theta. Now magnitude are equal. So magnitude of A is equal to magnitude of B. This is given. If A plus B is equal to 2 times the magnitude, so magnitude of A plus B will be what? Magnitude of A plus B will be, A plus B vector will be what? This vector will be root of a square plus b square plus 2ab cos theta. We have learned this just now. And have equal magnitude, and a plus b is this, is equal to 2 times the magnitude of a minus b. What will be the magnitude of a minus b? That will be root of a square plus b square minus 2ab cos theta. Now, how will you? They are saying that this is equal to twice. Magnitude of this is equal to twice the magnitude of this. So we will just equate these two. So this is equal to twice of this and equate these two. Square both sides. So you will have a square plus, please pay attention, b square plus 2ab cos theta is equal to 4. I am squaring both sides. A square plus b square minus 2ab cos theta. And you can see a is equal to b. So a is equal to b. So a square plus b square, a square will come out common. Let me substitute. If a is equal to b, magnitude a is equal to b. All these things are magnitudes. Please be attentive. I will substitute in place of b, I'll substitute a. So a square plus 2a square cos theta is equal to 4 a square plus minus 2a square cos theta. And now you solve this equation and you will realize 2 plus 2. A square will cancel from everywhere. A square will cancel from everywhere. And this will be 2 plus 2 cos theta is equal to 4. 2 minus 2 cos theta. Let's solve this. This will come out to be, open the equations. I think 2 will get cancelled. 1 plus cos theta is equal to, I'm just doing the calculation. 4 minus 4 cos theta. This will be 5 cos theta is equal to 3. So cos theta will be equal to 3 by 5. And the answer will be cos inverse 3 by 5. So C is the answer. How many of you got C? Yes, I can see some of you already got this answer. Good. So these are previous years IIT mains problems, and you can see they are not tough. All you have to do is understand that formula of finding the magnitude and use the information that is being given to you properly. Now, coming to the position vector. So vectors chapter, I just want to move ahead very quickly now. And I want to come to the real crux, which is mechanics. We could have done more problems, but I think it is better that you do these problems, mains problems at home, and try to do them on your own. If you will get stuck, I'll send you the solutions, or you can ask me in the next class. Displacement vector, position vector. Okay. Now, there is one important thing before we go on to mechanics. We can do some more questions after some time. If before we go to mechanics, how do we define the displacement? Now, before we come to kinematics, we start doing speed, velocity, projectile motion, circular motion, free body diagrams. Before that, uh, you can see the recording. Mrudesh, I've done this question properly. You can rewind it and see. Okay. Now, coming back to, uh, there is one very important thing that I want to tell you is that displacement. How do you define displacement? Please, everyone pay attention. Displacement of a body. All of you are aware that there is a difference between distance covered by a body and displacement of a body. What is the difference between these two? Just please observe. Suppose I moved from here to here, which is 10 meters. Now, then I moved this is suppose X direction, and then I moved in the Y direction, and that was 20 meters, or say 15 meters. I just want to keep it logical so that it doesn't appear to be strange, because the length that I'm drawing is something close to 15. Now, if these are two displacements, I moved towards east and then I moved towards north. So there is a vector, displacement vector from A point to B point, and then from B to C. I moved 10 meters along east, and suppose this is east. So this will be west, this will be north, and this will be south. This is what the convention is, east, west, north, south. And I am marking it again very clearly that I made a displacement of a body from A to B, and that displacement is 10 meters as shown. Then this is 10 meters. Then I moved in the direction which is shown here in towards north, which is 15 meters. So can anyone tell me how much distance I covered? Please reply. How much distance I covered? Distance. Yes, 25 meters. Correct. So distance covered is 25 meters. And what is the displacement that I had? Displacement is the people have crammed this definition, and please try to understand this. Displacement will not be 25. Distance is 25 meter. Yes, I agree. Everyone has replied. Displacement will be how much? Displacement will be the vector joining the initial position. This was the initial position, and this is the final position where I have reached. No, displacement is not zero. Please pay attention, everyone. Displacement is the vector joining the initial position. I was initially here. Initial position. You have to learn this very carefully. And this is the final position where I've reached after these two displacements. Now the vector joining the initial position to the final position is this. And this is going to be the displacement. Displacement. Now, all of you, please note it down, understand it. And displacement is not 5 or 25. Distance covered was 25 meters. This actual path that was covered when I was moving was this path, which was 10 meters. This path, which was 15 meters. And total distance covered was 25 meters. I agree. But the displacement is not 25 meters. Displacement is, now please note it down, everyone. This line I want all of you to note down. Displacement is the vector. Write down, please. Displacement is the vector joining the initial position to the final position. Please write it down. This is called displacement. Now I will draw this vector. I have drawn this vector with white arrow, and that is called displacement. Now displacement will be, if you see the Pythagoras theorem, root of 10 square plus 15 square, the magnitude of displacement will be root of 10 square plus 15 square square root. This will be displacement, and the direction is as shown in the figure, and you need to start understanding the difference. Yes, 325 is the answer, Mega. I completely agree, and that is the answer. And I think some child has taken out the square root. That is fine. Now, before going to other topics, dot product, cross product, we'll come to the application of these soon. But before that, now let's, because we have begun our journey on the path of kinematics. I want to continue on that path, and I can see there is a better response and you are understanding it. So we understood that there is a difference between distance and displacement. Now tell me, one is distance is, please note down this, distance is the actual path covered. Sorry, my handwriting is really bad right now because it's too slippery, my screen. I will get this correct. And displacement, how do you define displacement? Displacement is the vector joining the initial position to the final position. Please note down this. Yes. So actual path covered, and this is a vector. So displacement has a direction, distance has only magnitude. Distance will be like d, the symbol is generally d, and displacement is written as s with a arrow over it. Now, can you tell me the difference between speed and velocity? Speed is defined as distance covered upon time taken. What is displacement? Displacement is, what is velocity? Velocity is, what is the difference between speed and velocity? Velocity will be equal to a vector, and velocity is defined as displacement upon time taken. Now, speed is a scalar quantity because distance is a scalar quantity. Displacement is a vector quantity. Therefore, velocity, which is displacement upon time, that is a vector quantity. Please understand this. Now we are coming to, you have heard, how do we define acceleration? Acceleration is rate of change of velocity divided by time taken. This can be written as final velocity minus initial velocity divided by time taken. Now, if I cross multiply time here, you will get V final is equal to V initial plus AT. Now, this is equations of motion, which you have learned. So, wait a sec. Something shifted. 1 second. Now, this is one equation of motion which you must be remembering. V is equal to U plus AT. But please understand, here V is a vector, U is a vector, A is a vector, and V is the final velocity, U is the initial velocity, A is the acceleration. This is one. Can you tell me other equations of motion? S is equal to UT plus half AT square. Where what is S? Displacement. This is not distance. Please remember this. S is displacement, U is the initial velocity, A is the acceleration. There is another equation that you remember, equations of motion mein. Is there any other equation you remember? V square is equal to U square to plus 2AS. Yes, here it is magnitude ka square. V square is equal to U square plus 2A dot S. But right now I'm writing 2AS. Now, in vector form, these are the equations of motion. And, oh yeah, sorry. Now, good. These are called equations of motion, and you must have done questions based on them. And I want to make you more clear in the same questions, and you will understand how. Just see this. When you are doing questions of kinematics, first question that I want to do is to check whether you have understood the difference between distance and displacement, and you are able to do questions based on that. Just see this. I am going to do a motion in these directions. A body goes from A to B, then he goes from B to C, perpendicular direction, and then he goes from C to A. Simple question. I want to check your conceptual clarity. A body started from A, went to B, went to C, went to D. These are 90 degrees, mutually perpendicular. This was 20 meters, this was 10 meters, this was 20 meters. You have to tell me a body started from A, went to B, went to C, then went to D. This was the path it followed, and it reached D. Now my question to you is, and it was moving with a uniform speed. It was moving with a constant speed. Now you have to tell me, suppose it took 10 seconds for this total motion, 10 seconds. What is the average speed from A to D? First question is average speed from A to D. Second question is average velocity from A to D. Please tell me these two answers. Average speed, average velocity. Yes, average speed. Many people are answering correct. I am impressed. It is 5 because the total distance covered is 20 meters plus 10 meters plus 20 meters. So total distance covered, average speed is defined as total distance covered upon total time taken. So the answer to the first question is average speed will be equal to total distance, which is 50 meters, divided by total time taken, which is 10 seconds. So the average speed was 5 meter per second. Many of you have already answered this. Now you have to tell me the second part, which I'm very keen on. What is the average velocity from A to D? I want to see clarity here. Average velocity. Yes. Siddhi, I'm impressed. Given the right answer, first child to give. Average velocity, Vishwanath is the, oh, many of you are giving me the right answer. Just please be attentive and see. What is the net displacement, total displacement? I just told you the definition of total displacement is, this is the initial position, this is the final position. The vector joining the initial position to the final position gives you displacement. This vector is the displacement vector. So total displacement is how much? 10 meters only. And average velocity will be total displacement. So we are writing the answer to the second part now. Average velocity will be equal to 10 divided by 10 meters divided by 10 seconds, which will be 1 meter per second. But this answer is not yet complete. Please, everyone, be attentive. 1 meter per second. Those who have answered are very clear, but you have to understand this is average velocity, but velocity is a vector. You have to specify the direction also for sure. So you will say 1 meter per second in the direction. What is the direction of average velocity? Direction is along AD, this vector. Direction is also equally important for any vector. You cannot just tell its magnitude and you are done. No. So average velocity will be, the magnitude is 1 meter per second. But if I tell you V average in vector form, you will be writing 1 meter per second and a unit vector along AD. This is the correct representation. Yes, Hamish. Good, good, good. I can see that. So children, please be attentive. Now so earlier I was dealing with vector, which was a little slow, little boring, but now I can see a lot of participation and I'll be giving you questions. And let's see, I am impressed. Those who are answering one and those who have understood this, I am impressed that they have understood the average difference between distance and displacement, and they are also understanding the difference between average speed and average velocity. Good. Now let's move fast. Alert. So now if I give you a question, so average speed, velocity, these I know. Always remember when we are applying equations of motion, which we just understood, there are v is equal to u plus at, v is equal to just a second. First of all, understand these are vectors. Time is a scalar. S is equal to ut plus half at square. What is S? Is it distance or is it displacement? First, what is S? Distance or displacement? I want response. Yes, displacement. It is not distance. Good, 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 good. We will pick up speed. We will get into interesting concepts. Just keep paying attention. Yes, it is displacement, not distance. Very good. And V square is equal to U square plus two AS, A dot S. No. And now I'll show you how efficiently you will be doing questions based on them. Just see this. See this question I'll be giving you. If I throw a stone upwards, very basic question I'm giving you. And the next question will be very intelligent question. So you have to pay attention and take interest. I am throwing a stone upwards with 100 meter per second upward velocity from the ground. The stone will go up. It will go up, then slow down, and then it'll start falling back and it'll fall back to the ground. What is the total time of flight? Please tell me. I will be impressed if you do it right. And though it is a simple question, but I want you to learn something here. I have thrown a stone initially vertically up with 100 meter per second speed upwards. Acceleration due to gravity has to be taken as 10 meter per second square. And all of you are aware that acceleration due to gravity, we can assume it to be 10 meter per second square right now, because I am not interested in making you solve in decimals. I am more interested in making you learn this concept. And its acceleration is always downwards, vertically downwards. So many of you started answering it, and you are answering it as 20 seconds. Yes. Let's see. It is important. The answer says zyada important hai. What was your approach? And Ramya and Vijayanti and Siddhi, you have to tell me if you did it with the right approach or not. Because the next question will ensure that you will not be able to solve if you didn't do it with the right approach. Just understand this. I have thrown, okay, I will explain again. The question is, I am throwing a stone upwards. There is a stone which I am throwing upwards with a speed of 100 meter per second in upward direction. It will go up, and then acceleration due to gravity is acting downwards. Its speed will keep decreasing, and then it will reach the maximum height, and then it will start falling down, and finally it will reach back on the ground. What was the total time of flight? This was the question. And many of you have answered it to be 20 seconds. And let me see if their answer is correct. I will show you a very smart method of solving the same question. Let's see. Learn it. So what we'll do is we'll write down the information that is given to us. Where is the initial position of the stone? On the ground, here. Where is the final position of the stone? On the ground, here itself. The stone has reached back here only. What is the displacement? Can anyone tell me what is the displacement of the stone in this whole process? Please tell me. Displacement only. Just answer. Displacement is how much? 0. Yes, correct. Initial position is here on the ground. Final position is here. And the vector joining the initial position to the final position gives me displacement is 0. Initial speed is 100 meters per second upwards. And acceleration is 10 meter per second square downwards. And I have to find out the time. I will assume whichever direction I want to assume positive. Yes, yes. Many of you are responding. Now I'll change the gear. Upward direction to be positive, downward to be negative. We'll use which equation in these four variables? Time is to be asked. So S is equal to ut plus half t square. So 0 is equal to 100 t plus half minus 10 t square. And from here, you will get 200 t minus 10 t naught square. 2 idhar chala gaya. Now, t naught is 0 is one solution for this quadratic equation. The other solution is t naught zero, t naught is equal to 20 seconds. Many of you gave me the right answer. Now, so I understand those who gave me the right answer. If you can crack the next question correct, I will be royally happy and impressed. And let me see what is your solution to the next question. Please be attentive and understand the question. I am standing on top of a building. This is a building which is 200 meters high. I am going to throw a stone upwards like this. And I'm going to throw a stone upwards with the initial speed of 100 meters per second, vertically upwards. I took out my hand a little bit and threw it upwards with initial speed of 100 meters per second. This stone will go up and it will keep going up. It will reach a maximum height. Then it will start falling down, and it will reach the ground. And the ground is here now, which is because I am standing on top of a building which is 200 meters high already. So this stone started here, went to a maximum height, and then fell to the ground here. This time, if any one of you gives me the right answer, what is the total time of flight of this stone? Total time for which the stone was in air before hitting the ground. I will be impressed. No, 20 seconds is not the answer. Please be very careful. This is a different question. 20 seconds was the answer in the previous question. When the stone was going up from the ground, it was going up from here and it was falling at the same level. It was reaching here. Right now, that is not the case. The stone is going up here, reaching the maximum height. And then from there, it is falling down, and reaching the ground. This is the total time of flight that you have to find. And that is not 20 seconds. And that is also not 30 seconds. So please be attentive. If you do it right, that is impressive. And if you have understood the previous approach, no, you are just Manju Deepu, that is not the correct answer. I think Mohini Pujari has given the right answer. Let's see. I am not very sure. I'll try to do it and then tell you. Let's see. Okay. So we will follow the correct approach and just everyone pays attention and learns the right approach. Answer अपने आप राइट आएगा if you have understood the approach. Please pay attention to the approach. Let's see. I'll try to solve it and let me see how many of you get the hang of the right approach. Just observe the motion and tell me what is the initial position. Please tell me, everyone, what is the initial position? Is the initial position here? Can I write I here? Yes or no? Initial position is here. Forget about the answer right now. We'll get the answer. I'll solve it for you. Is the initial position here at this point where I have marked it with the right red color? Is this the initial position? Okay, I will see the answer. Wait, I'll show you. This is the initial position of the particle. Where is the final position? Thank you. Where is the final position? This is the final point. Can anyone tell me what is the displacement of this particle? Displacement. Who can tell me the displacement? Please answer. Yes, displacement in terms of meters. Yes, yes, correct answers are coming now. 200 meters. Join the vector from initial position. Displacement is defined as the vector joining the initial position to the final position. This is the initial position, this is the final position, and this vector is 200 meters. So displacement is 200 meters downwards. Nothing else to be seen. वो बीच में क्या गया, ऊपर गया, नीचे गया, वो भूल जाओ. Beach में acceleration was uniform, and that is what we know. If acceleration is uniform, then we don't need to worry about beach में किधर किधर घूम घाम के आया वो. Finally, initial position is this, final position is this, and the vector joining the initial position to the final position is said to be the displacement. This is this. Acceleration due to gravity is 10 meter per second square, which is downwards. I have to find initial velocity. Initial velocity U was 100 meter per second upwards, and time I have to find out. Now, because we are dealing with vectors, I will put every vector with proper sign. What is the sign of each vector? Let's see. I am assuming downward to be positive direction. Suppose I can choose any direction to be positive. So positive, positive, negative. And let's keep the values. S is equal to ut plus half at square. Let's solve this. S 200 is equal to ut minus 100t plus 5t square, half at square. From here, 5 gets cancelled. So t square minus 20t minus 40 is equal to 0. So t is equal to what? I'll get the answer. T is equal to quadratic equation minus b plus minus square root of b square minus 4ac upon 2a. So the answer will come out to be 20 plus minus root 560 by 2, which is 10 plus minus, okay. No, 10 second is not the answer. Please, everyone pay attention. And time cannot be negative. So we will take the positive root only because root 560 is bigger than 20. So 10, we will omit this minus sign because time cannot be negative. So root 560 2 से डिवाइड कर दीजिए, 4 बाहर ले आइए. This is the answer. Seconds time. How many of you got this answer? Honestly, please tell me. Which will be 140 can be written as 12 square is 144. So I think 22, 21.8. Raju gave me 21.8. Many of you have given me this answer. Good, 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 good. Right. Have you understood it? Rishika, 10 Negative root we will omit because negative time cannot be negative. And so those who were giving me, so Sharvya, Ramya Nayak, Mohammad Gose, Sudarshan Shitole, Ramya Nayak, Bhavna, Bhavya, all these people have given the correct answer. Elizabeth says, I have got the answer, sir. Good, 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 good. So, but have you understood the process? This is a smart way of doing questions. And please, Naveen, Solocha, all these people have got the right answer. And if you are getting the right answer, you will enjoy the next things that we will be learning. I am not going too much into vector, vector, vector. That was becoming boring. We are now getting into kinematics, and kinematics, we just did one question of learning how to solve equations of motion. And I made you very clear that we are dealing with vectors. I also made you very clear when you are dealing with vectors, it's very important to keep the right sign. It's very important to observe the displacement and then use them. Use them. Now, coming back to, okay, equations of motion हमने थोड़ा सा किया. Now let's come to kinematics के दूसरे part. I will quickly touch upon the projectile motion now. Just all of you please pay attention. If I throw a stone in this direction with initial speed, now there are very small things which are very confusing for children at an angle theta, and this is say 100 meters per second. Now, because all of you are in 12th, I am assuming that you already know a little bit, thodi cheezein. If you don't understand anything, you can always ask me to repeat. I will do that. And because it's my first session with you, so it'll take me some time to develop that rhythm. And a good conceptual part will begin now, where I will be teaching you very beautiful concepts and you will develop that clarity in your thought process. Just be patient and attentive. The rhythm is setting in now. Coming back to projectile motion, if I throw a stone at an angle 30 degrees from the ground, aiming it at an angle 30 degrees with the initial speed 100 meter per second, as shown in the figure, this stone will move in air like this and fall down on the ground somewhere. This is my initial position. This is my final position right now. If I ask you this total distance it covered on the ground, this is called its range. This is a point where it attained maximum height. So this is the maximum height of the projectile that it attains. And I may ask you what is the maximum height attained. I may ask you what is the range. I may ask you a lot of questions based on projectile motion. But to derive all these and to solve all the questions of projectile motion, all you have to do is you have to learn the concept properly, how we will be solving questions using the information that we have. Just pay attention and see how we will be solving projectile questions. Please pay attention. Everyone will answer. What is the horizontal component of velocity initially just after the stone has been thrown? What is its initial horizontal velocity component? It will be, as shown in with red arrow, it will be 100 cos 30. Yes, initial horizontal velocity will be this, and it will be horizontally. What will be the initial vertical velocity? Initial vertical velocity will be 100. We are resolving this vector. A cos theta, A sin theta. 100 sin 30 will be the initial vertical velocity. It will be upwards. It will be towards the right. All of you are aware of it, right? Good. So these are the initial velocities of the stone when it has been thrown in air. Just after the stone has been thrown, initial velocities are these. Now, when the stone is in air at any position, is the stone going to be is the velocity? What is the acceleration of this stone at any point? There is only one force which is acting on this stone, and that force is gravitational force. And that force will give it an acceleration g downwards. There is no other horizontal force. I am assuming air resistance to be zero. There is only g, which is its acceleration, and that acceleration is due to gravitational force. So acceleration mg is the force, and acceleration is mg divided by m, which is g downwards. So its acceleration is g downwards. And now I'll just mark its acceleration here. So its acceleration everywhere is g. Now, in horizontal direction, there is no force. And if there is no force, will the horizontal velocity change? Will this horizontal velocity change anywhere? No, it won't. So initially it was 100 cos 30. At every point, it will remain 100 cos 30. At the maximum height, also, this velocity will remain, horizontal velocity will remain 100 cos 30. It will not change. At every point, the horizontal velocity remained the same. It didn't change because there was no horizontal force. So unless there is a horizontal force, there will be no change in horizontal motion. Now, for the vertical motion, initial vertical velocity was this. And this velocity started decreasing because acceleration due to gravity was acting in downward direction. This velocity was in upward direction. And this kept on decreasing, decreasing. And at the highest point, what was the final vertical velocity? 0. At the highest point, final vertical velocity was 0. There are times when children are confused that when the stone has fallen at this point, the velocity final will be 0. No, please, we do not take that velocity to be 0. We take velocities just before hitting the ground and just after leaving the hand. So don't fall into that trap. Here, the velocity is not 0. Just before hitting the ground, it is not 0. And we will apply equations of motion. So at the highest point, the velocity is 0. Yes. Not at this point. यहाँ पे 0 नहीं है. ये अच्छे से समझ लीजिएगा. ये after falling down is 0, but just before falling and hitting the ground, it is not 0. Just before वाली velocity लेते हैं हम. ये ध्यान रखिएगा. Now, okay, I will now show you. If you do any question now on projectile, it will be very easily done. Suppose I tell you, find the total time of flight. Now I'm drawing a neat diagram so that everyone is on the same page, understanding it clearly. Now, please pay attention. If there is a projectile which is thrown like this, 100 meter per second, or let's say u is the initial speed, and we throw it at an angle theta with the horizon. So the initial horizontal velocity will be u naught cos theta. Initial vertical velocity will be u naught sine theta, which will be upwards, and this is towards right. And this stone will move like this and go and fall down on the ground somewhere. And we have to find, suppose, now the first part is, I want to find the total time of flight, or I want to find the maximum height attained, H max. Anything can be found. Now, tell me what is the initial position, what is the final position? Who will tell me? Initial position of the particle is this. And final position that I'm talking about maximum height attained. So I'm interested in this point. So at this point, for us right now, this is the final point of consideration. Now, between these 2 points, what all do we know? Let's study the vertical motion. Vertical motion and in horizontal motion will be independent of each other. Only common factor will be time. Now, vertical motion we are studying. What will be the initial vertical velocity? It will be u sine theta. Initial vertical velocity will be u naught sine theta upwards. What is the acceleration in vertical direction? G downwards. What is the final vertical velocity at this point. What is the final vertical velocity? 0. Suppose I have to find maximum height. So displacement vertical I have to find. What is the displacement? So at this point, this vertical displacement is maximum height attained. And this is also vertical displacement. Now, which equation should I use? V square is equal to U square plus 2AS. And you will be able to get the answer. And if I use these equations, V square 0 square is equal to u square sine square theta v square. I am assuming upward to be positive, downward to be negative. We'll put it with proper signs because we are dealing with vectors. V square is equal to u square plus 2a s we have to find out. So from here, s vertical is u square sine square theta upon 2g. And that is a formula that many of you remember. Now, let's continue. So this is the maximum height. If I ask you what is the total time of flight? Total time of flight for this projectile motion, quickly you have to answer. Then I'll give you a challenging question. So total time of flight will be, this is going to be the initial position now, this point. If I'm going to find the total time of flight, this is going to be the final position now. And I'm talking about what is the total time from here to here. So initial position is here now, final position is here now. What will be the, let us see what is the information we have. What is the information we have when we are trying to, 1 minute, let me rub this. Now, for me, this is the initial position, this is the final position, and I want to now at this point, I want to find the total time of flight. Let's see for vertical motion, what is the information that we have? Initial, oops, now, initial vertical velocity for vertical motion. Initial vertical velocity is 100 or u naught. Initial vertical velocity is u naught sine theta upwards. Initial acceleration in vertical direction is always going to be g downwards, meter per second square and all. Now, what is the displacement in vertical direction from here to here? Please tell me. Initial position is this, final position is this. What is the vertical displacement? 0. And we have to find out the time of flight. For vertical motion, which equation should I use? Using these 4 unknowns. S is equal to ut plus half at square. So we are assuming upward to be positive, this to be negative. S is equal to ut plus half at square u sine theta into t naught minus half gt square. And from here you'll get t is equal to 2u sine theta upon g. And these are standard things that are given in all your books, and you will be able to know these results for projectile motion. Now let me give you an interesting question and see if you have understood what we have been learning in solving these questions. How many of you will be able to solve this question? I will be very impressed if you are able to solve this question. Let's see. Pay attention. There is a building, same building which I was standing on earlier, which is 200-meter high. This is a 200-meter tall building. Now, I am going to throw a stone at an angle from the rooftop with 100 meter per second speed at an angle 30 degrees with the ground. Now, the stone will go like this and go like this and then fall on the ground. Now, all the formulae that you have crammed till now for projectile motion were for ground, were for ground to ground. All the formulae that you had learned for projectile motion earlier, they were from ground to ground. So there will be no direct formula that will be applicable here. And therefore, you have to do this question originally from original approach. And I gave you the question to be that you are on the rooftop of a building. Where is the question? Where it? I'll draw it again. So the question is this, all of you, please pay attention. The question is this, you are on the rooftop of a 200-meter tall building, 200-meter tall building. From there, you are throwing a stone at an angle 100 meter per second. It is going at an angle 30 degrees with the horizon. And this stone goes up like this and it falls down on the ground at a distance somewhere. How many of you can tell me what is the total time of flight now? Please tell me. Before it hits the ground, total time of its flight. Let's see how many of you can do it correct. Acceleration due to gravity will be 10 meter per second square. I'll be very happy if you answer it right. What is the total time of flight? It's not going to be an easy question. You cannot apply a direct formula. So just please pay attention and try to answer it. No, 100 seconds is not the answer. Murdesh. 200 seconds. No, this is not the fluke thing that you have to do. 100 seconds. No. Are you applying some direct formula so that you are answering it so fast? Because it is not going to be that easy. You have to use your basic approach. You cannot use any direct formula here because your direct formula for projectile motion that you have crammed are based on the assumption that the projectile started from the ground and it fell on the ground at the same level. And you derived all your formulae based on that. Here, you will not use that. So Sudarshan is answering something which I would like to have a look at. And let's see how many of you can answer it. I'm seeing the screen. You will not be directly using any formula. You will use the original approach. Now just see this. It's a simple question. If you are using the right approach, 100 cos 30 will be the initial horizontal velocity, which will be 100 cos 30 horizontally. Initial vertical velocity will be upwards, which will be 100 sine 30. You resolve the velocity in vertical and horizontal direction. Now, for time, let's study the vertical motion. Where is the initial position? The initial position is here. Where is the final position? Here. If I have to find the displacement, the total displacement of this body is this. This displacement has a vertical component, it has a horizontal component. What is the vertical displacement of the body from here to here? The vertical component of the displacement is this, 200 meters. This is the horizontal displacement. And the total displacement is this vector plus this vector. This is vertical displacement. This is vertical displacement. This is horizontal displacement. And this is total displacement. Please understand this. Now, when we are studying the vertical motion, let's see what all do we know in the vertical motion. I will try to write down and see initial Let's see. Initial vertical velocity. What is initial vertical velocity? It is 100 sine 30, which is 100 sine 30, which is 50 meter per second upwards. What is acceleration in vertical direction, which is 10 meter per second square downwards. I want to find time of flight and displacement in vertical direction. I already know. And what is the displacement? 200 meters, vertical displacement. And this you have to use S is equal to UT plus half AT square. I'll keep the values quickly. I am assuming downward direction to be positive. So plus 200 S is equal to UT. This will be minus, this will be plus. I've assumed downward direction to be plus. So S is equal to UT plus half T square minus 100 sine 30 is half into T plus 5T square. Now, this will be 5T, quickly solve 5T square minus 50T is equal to 200. So 5 gets cancelled. T square minus 10T minus 40 is equal to 0. You can solve the quadratic equation. Okay. T is equal to minus B plus minus B square minus 4AC upon 2A. How many of you got it right? Let me see. So this is 5 plus root 65. 260. 260. 4 बाहर आ गया. 4 is 160. B square minus 4AC. So this is, I'm just looking at your answers and I'm trying to figure out, has anyone answered it correct? 5 plus minus, this is 260. Root of 260 can be written as yes. Root 65. Yes. Okay, correct. So 5 plus root 65 is the answer. And one child has been writing this answer for a long time. Rani, Ramya, very good. Very good. Very few people have done it right. I'm impressed by you people. I would like to 5 plus root 65, and maybe these children, root 65 is almost 13 point something. Yeah. So all those who are giving this negative time, Marudesh, this negative time cannot be negative. So eliminate the negative wala time, and 5 plus root 65 is the correct answer. And many of you have given this answer. Great. Good, good, good. And I am extremely happy that you people can get this answer not by any direct formula. You can only get this answer if you know the right approach. And those who know this right approach are the students who will surely make it to IIT. Trust me, if you have learned the concepts properly. Now, wait a second. This is 8 o'clock to be going soon. And I was very baffled with how to go about it, where to begin. Vectors, should I strengthen or should I continue doing equations of motion and laws of motion and all, rotation and all? So I will take you, see, this rhythm is setting in, and I am realizing that some of you are responding, some of you are not responding. I will try to keep this class little light today and not rush into things. From the next class onwards, I will keep concepts and questions based on those concepts for practice, where the calculation should not be much, but I need to know your approach. For example, let me give you an illustration what I want. Now, let me show you how you will be coming prepared for the class for the next lecture. And I will be taking these lectures every alternate day for some time, or maybe uh, yeah, every alternate day. There are other subject teachers also who are teaching. So once in a while, some other subject lecture may happen. But for physics, I will be taking the lecture and I will ensure right from the basics, vectors we touched upon, kinematics we are touching upon. So there are a lot of confusions of students in pseudo force, circular motion, free body diagrams, then rotational motion. And trust me, I will give you full clarity in that. The only thing I want from all of you is please be attentive, please take proper interest. And today was like the first time I was very puzzled that I knew that there are around 100, 200 students who are joining from Karnataka and they want my full lecture in English. That request was made. And because of that, and someone made a request, I wanted it in Hindi, but then I realized that because I have promised them that I'll be teaching in English, I cannot shift. Keeping all these things in mind, ठीक है, good. All those students, Kannada, Ramya, dear, I am really sorry. I do not know Kannada, so please bear with me that I can only explain to you in English. I can explain physics concepts with a lot of clarity. I will make you understand the fundas properly, all those collision, rotation, all those problems. But my only problem is I do not know Kannada. So please bear with me. Okay. Okay. Your feedback is important. I request you, if you people are facing any issues or any challenges with your Karnataka learning, I will, you can write an email to me. I'm writing my email ID here, Praveen @eduisfun.com. Please use this email ID. Write to me, the female. I'll definitely listen to you, understand, convey your feedback. Continue daily classes physics. I can do that. If I get that much time, I can definitely bring a lot of change and deliver. How many of you understood the lecture? I want to know that. Just give me a yes if you understood the lecture, because I was finding it a little not, I was not very happy with myself. I was not giving able to give my best today. Still, if you are saying yes, that means a lot to me, because in the next lectures, I'll definitely much more organized and clear. Great. So if despite all this, you still like the lecture, I am really, really glad that you are giving me so much appreciation. So sweet of you. I will clear all your concepts, that I can assure you. I have trained a lot of students for international Olympiads. I have been teaching for so many years. My physics is strong. Just that this technology platform and this tab writing, this is all taking me a little, making me a little nervous. But I can see a lot of students understood. And if we keep learning physics every day, I don't mind teaching you more number of days. I just want to bring change in you, improve your physics, and I thank you so much. English is acceptable by almost all of you. Okay. Thank you so much. Thank you so much, everyone. From the next class onwards, I assure you, I'll make it worth. Every lecture will be for sure worth attending, because your concepts will keep becoming better and better. So in the next lecture, I promise I will be much more effective. Thank you so much. A lot of people are already complimenting, but trust me, I have not been 10% effective also compared to what I can. So I will try to give my best in the next lecture. Thank you so much, everyone. That is very, very sweet of you. So many compliments, so many children saying good things. Thank you so much. The next class, I'll keep it tomorrow itself. I don't want any discontinuity. There are lectures for, so what we'll do is Monday, Wednesday, Friday, they have kept one day for physics, one day for maths, one day for biology. I think chemistry. Biology lectures are not happening right now. So what I'm saying is for physics, chemistry, maths, alternate days. But what we can do is we can keep the class tomorrow itself. If you people are enthused, 6 to 8, generally you people are home. How many of you are wanting that we should keep a class tomorrow itself? Tomorrow. Just type tomorrow. I want to see how many of you want the class tomorrow. So sweet of you. So many of you are saying good things. And trust me, I have not given my 10% also. I am not myself happy with my lecture because I was little puzzled with what level of difficulty, what should I do? And this whole technology tab was a little discomfort thing. Tomorrow. Okay. So many children are keen to learn tomorrow. So I will fix the lecture tomorrow. I want all the sincere students to attend. Great. Till I strengthen your mechanics and your full physics, I will keep the lecture almost daily. Only on those days where I am not. So let's plan the lecture tomorrow. I am okay. I understand for a sincere student, it's very important to get that help and support and clarity. I assure you, every day 2 lectures, एक महीने में ही strong कर दूंगा mechanics और physics में. So let's keep the lecture tomorrow, team. I request all the team members who are listening to me, keep a lecture 6 to 8 tomorrow also. ठीक है? ठीक है. Let's keep it daily almost. Only when once in a while, if I have something else lined up, then we'll not hold the lecture. Otherwise, almost every day I'll hold this lecture, and I am extremely happy for a teacher listening to such compliments that children are wanting to study. That's a very, very beautiful thing. Thank you so much, children. This is so sweet of you. Tomorrow, done. I'll teach you tomorrow. Ayush, you have noted it. Please ensure that you organize the class tomorrow. Done. 6 to 8. And tomorrow we will be learning kinematics, projectile motion, circular motion with full clarity. Please be attentive. I'll make you solve IIT mains advanced problems with ease. All you have to do is be attentive, learn the right approach. I am extremely happy. There were so many students who were able to solve this last projectile question, which cannot be directly solved with formula learning. So if you have understood the right approach to solve such questions, you will be really enjoying. Yes, I will ensure that this level of difficulty is not too much. So anyone who's aspiring for NEET also will also benefit for sure. Conceptual clarity, I will not go too tough of IIT JEE advanced level. I'll stick to JEE mains and NEET. Thank you. I'll take care now. ठीक है, children. Let's meet tomorrow at 6 o'clock. Yes. आज के नोट्स तो यार रहने दो. आज तो मुझे भी बहुत ज्यादा मजा नहीं आया है, वरना मैं. चलिए ठीक है, we'll share it. Ayush, you can share today's lecture and notes with the students. Tomorrow onwards, I'll try to make it more organized and beautiful for all of you. Okay? Thank you. Bye bye, everyone. Wish you good night. And it was amazing to see sincerity levels being so high. I am sure you children are really working hard and paying attention. I will make all this effort worth. Thank you so much. Thanks. Take care. Bye bye.